Hello, my name is Anthony Meyer, and I go to Georgia Southern University, and this is my individual research project for the instrumental analysis class there, and I did it on the scanning electron microscopy. So what is scanning electron microscopy? And what it is you use a scanning electron microscope, and it is an instrument that utilizes an electron beam to produce an image of a sample surface. And this is capable of analyzing very small samples down to the nanoscale so that you're able to identify surface morphologies and take very high resolution pictures. So a little bit about the instrumentation, about how this works. You start with the electron gun, and it produces a very focused electron beam that travels through the magnetic condenser and objective lenses. And the scan coils are controlled by the computer to where you can actually adjust how you would like to focus the beam using them in conjunction with your magnetic lenses. Once the incident beam gets past those, it impacts the sample and produces X-rays, backscattered electrons, and secondary electrons. The backscattered and secondary electrons are what is detected by the electron detector, and they produce the high-resolution image that you see from the instrument most of the time. The X-rays are detected by an X-ray detector in the EDS, and that is an extra attachment, and it can also be displayed on the computer as an estimate to the surface elemental composition. The whole system is done under high vacuum in the chamber so that the electron beam is not scattered. And the beam impacts a sample, produces backscattering and secondary electrons, and it produces X-rays, cathode luminescence, and transmitted electrons through the sample. Electron detector detects the backscattering and secondary electrons only to produce a high-resolution image, and that is your qualitative data, as well as being able to give the size comparison of surface samples, and that's going to be your quantitative data. The EDS additional attachment gives an X-ray detector to pick up these X-rays, and it shows the different contents of elements on the sample surface. One of the applications is in an article of preparation of superhydrophobic films with fluorinated copolymer. The authors actually combined the low surface energy of fluorinated copolymers with the high roughness of silica particles to produce this lotus effect. And what that does is it gives a self-cleaning effect because of the high contact angle that's produced from the combination. Using the SEM, the authors were able to actually examine one of the problems they were having, because once you got above about 20% silica particles, the contact angle started to drop off again. Well, the adjustment above 20% weight percent of silica particles actually began filling in the roughness gaps, and the authors were able to see that and adjust their techniques to that because of the SEM instrument. Here are the references that I used for this presentation, and I hope you enjoyed it, and thank you for listening.